So in this lesson, we will justify geometric statements using definitions, postulates, properties, and theorems. There's no particular reason I circled those or underlined these. Just know that we're justifying statements. We're going to use these definitions here, these properties here, and there are some postulates and theorems that we learned about already. You'll see some things on here like not supplementary, you know what those are, but like alternate interior angles, and some of this we've gone over before and we'll review later. I just have this ready because we're going to use this template a little bit more in future lessons. So we have a statement. Example 1 says if angle ABE is a right angle, so right angle, then the measure of ABE is 90 degrees. So what is the justification? How do we know that if it's a right angle, it is 90 degrees? We know that because that is the definition of a right angle. A right angle is 90 degrees. If an angle... I don't know why I was talking. That's why. Right angle. So this is a definition of a right angle, which means that if it's right angle, it's 90 degrees. If it's 90 degrees, it's right angle. So that's why we know that's true. So let's look at example 2. It says if angle 2 is congruent to angle 1, and angle 1 is congruent to angle 5. Okay, so I'm going to have to look at this. So if angle 2 is congruent to angle 1, if angle 2 is congruent to angle 1, and angle 1 is congruent to angle 5, then angle 2 is congruent to angle 5. Okay, so if angle 2 is congruent to angle 1, and angle 1 is congruent to angle 5. So angle 2 to 1, and 1 goes with 5. That means that angle 2 is the same as angle 5. So if you look over here, so if this looks like it's the transitive property. That means if angle 2 is the same as angle 1, and angle 1 is the same as angle 5, then that means angle 2 is the same as angle 5. All right, that is called the transitive property. It's that deductive sort of reasoning, like to a T right there. This leads to this, this leads to this, so that means this goes to this. Example number 3. If B is the midpoint of AC, so B is the midpoint. Let me change the color actually. If B, what's something I haven't really used? I guess I've used all the ones that are really going to show. Oh, I guess I could use blue. Okay, so if B is the midpoint of AC, then AB is congruent to BC. So this is a midpoint which breaks this up in half. So that means AB is congruent to BC. That is a midpoint. That's just the definition of a midpoint. It splits it in half. Midpoint. And if you look over here, there's midpoint, definition of midpoint. Okay, so example 4. If measure of angle 2 plus measure of angle ABE, I don't know why I did use the number here and this, maybe, I don't know. So a measure of angle 2 plus ABE equal measure of DBE. So DBE. Oh, okay. So I took this angle and I took this angle, and it's equivalent to this larger angle. We know that we just know if we add these together and we get the sum of both, it gives you the larger angle. This is just the angle addition postulate. This is one of the early ones you learned. The angle addition postulates. Okay, we have one more. If angle 1 is supplementary to FBG, okay, if angle 1 is supplementary to FBG, so FBG, so angle 1 is supplementary to FBG, then angle 1 and FBG equals 180. Oh, it just, I don't know why I went through all that work. It's supplementary. Supplementary means they're as a pair, they add up to, or the sum is 180. So that's, if they says they're supplementary and then it says that they add up to 180, then duh, because that's the definition of supplementary angles. So, thank you. That's it.